Now that we know how to prove that triangles are congruent, we can move beyond. Before we do, let's have a brief review discussion. The side-side-side, side-angle-side, and angle-side-angle postulates and the angle-angle-side theorem all help us prove that two triangles are congruent by using three congruent corresponding parts. The definition of congruent polygons then says that all other corresponding parts are also congruent. So we can use the fact that corresponding parts of congruent triangles are congruent to help us move beyond congruent triangles. Many textbooks do refer to this as CPCTC. I will use the definition of congruent polygons, or DCP, because that's what it really is. So let's do a quick proof here. Let's prove that parts of these two triangles are congruent beyond what is given. So notice that we are given that angle KBC and angle ACB are congruent. We also know that segment BC is congruent to itself, segment CB, with the reflexive property of congruence. And we're also given that angle K is congruent to angle A. Well, geez, if we look at our markings now, you will notice that we have two pair of angles and a non-included side that are congruent to each other. That means that triangle KBC is congruent to triangle ACB because of the angle-angle-side theorem. Now, because the two triangles are congruent, we can use the definition of congruent polygons to show that segment KB is congruent to segment AC. So let's do a couple of informal problems here. We are going to name the postular theorem that says that these triangles are congruent, and then we're going to explain why the statement that's given is true. So in the first one, we need to explain why segment EA is congruent to segment MA. If you look at the figure, we're given that two angles are congruent and two sides are congruent by the markings. But notice that angle TAM is a right angle. That means that we can use the linear pair to show that angle TAE is also a right angle. And of course, the right angle congruency theorem says that those angles are congruent, so the triangles are congruent by angle-angle-side. The segments then are congruent because the definition of congruent polygons says that the corresponding parts of congruent polygons are congruent. Wow! To get the pattern here, prove the triangles are congruent, then say that the parts are congruent because of the definition of congruent polygons. Number two, we need to prove that angle U is congruent to angle E. In the figure, we're given two pairs of congruent sides. Well, segment JN is congruent to itself by the reflexive property of congruence, so the triangles are congruent by side, side, side. Ow! If the triangles are congruent, then their corresponding parts, in this case angle U and angle E, are also congruent. Do you see the pattern? We'll just keep doing that. Try some questions on your own, and then move on to the next video.